Hey Internet, today's topic is a mechanical design tutorial. It's a motor pulling a pulley system. So here's all the values given. We got 1,000 on the cart, 1,000 on counterweight, 750 on the load, 500 on the drum, 50 on the idler, and these are in kilograms of course. Gear ratio is 35 to 1. The efficiency of the load is 72%. Mass moment of inertia of the wheel shaft is 155. Shaft and coupling is 3.5. Our linear acceleration is 125 meters per minute in 2 seconds, and then it decelerates at the same rate. We're also given a friction torque. Okay, now we got 3 questions. We got to find the torque of the rope drum, the motor torque, and the braking torque of the rope drum. So once we solve for A, it's just a matter of switching the signs for C, and then we'll solve B last. Before we even do that, so we obviously got to find total weight of the drum and counterweight, which is just 2,250 kilograms and 1,050 kilograms respectively. Finding the acceleration, 125 meters per minute divided by 2 seconds divided by 60. That will give us 1.041667 meters squared. And then for the force, you got your gravity times by your mass, because F equals ma. So that'll give you 24 kilonewtons, or 24,416.25 newtons. Same process for counterweight, and you get 9.2 kilonewtons, or 9,206 kilonewtons, 0.75. Alright, so question A is calculate the torque of the drum. So torque is inertia times angular acceleration, so I times alpha. Okay, now we got given our inertia, so it's 155 kilograms meter per second, times by our angular acceleration, which is just acceleration divided by 0.5, because it is decelerating at 2 seconds. We're also given a friction torque, so we add that, and we subtract the counterweight force, and we add the rope force. So this is force times your distance, which will give you your torque for your counterweight, and your drum counterweight, which then you'll get 8,179.07 newton meters per second. The answer is obviously rounded down. I'm sure they've used rounded down numbers, but don't just trust me or trust the answer. Just follow the method, and you should see for yourself that you'll find similar answer. Okay, now to solve for C, same process, except we just switch the signs around, because it's asking for it at its lowest level, descending at its lowest level. So that means you got your counterweight torque going positively now, so that's why it's plus. And you've got your drum going down. So you just swap the signs, as long as you know why you swap the signs, because the direction of the cart is swapped. It's now going downwards instead of going upwards. So once you do that, you get your torque of 7,677.7 Newton meters. So as you can see, the signs are swapped. This one's a negative, this one's a positive, this one's a positive, this one's a negative. As long as you know what's going on, then it should be all fine. Okay, B. So finding the motor torque. So we know that torque is also equal to force times radius. By radius, it'll be radius of our rope. So if we just make them equal to each other because the radius is the same, what we do is then we equate the torque of the motor to the radius ratio, which is 1 because it's the same radius, times the torque of the drum, which then, if you write it out mathematically, it will be torque of the drum divided by the efficiency times the gear ratio plus the inertia times the angular acceleration times the gear ratio. And you can see the numbers here, and it's roughly about the answer. Again, the model answers were taken from rounded down numbers. I'm not sure what significant figures they use, but again, trust the method and you should get a similar answer. If not, and if by sheer luck that you get this in the test or something similar to this, at least you'll get points for the method. Okay, thanks for watching. Be sure to like and subscribe, share with your friends, ring the bell, turn on all notifications, leave a comment. I'm sure there's going to be a lot of mistakes. I'm sure you guys are going to point that out. Until next time, see ya.